Welcome to the lecture number 5 on positive displacement compressor. Now during this lecture we are going to see the next part, that is section 3 of this unit, that is the single cylinder compressor with clearance. So previously we have discussed there is no clearance. If there is no clearance, or that we have assumed that if there is no clearance, and we have done the analysis. Now in actual conditions there is always some clearance we have to provide for smooth opening of the valves, as well as to avoid the damage of the cylinder piston and cylinder head. So in actual conditions there is always the clearance. So what will be the effect of that clearance on the analysis, that we have to see for this lecture. So let us see that. So if we are considering that there is a clearance, then how the compression processes are occurring. So we will understand it with the help of the PV diagram. So if we are having the clearance, then there is that small volume VC will be there in between the TDC and that cylinder head. So the TDC will be somewhat away from that y-axis, and the BDC we can consider that from TDC to BDC there will be stroke. So the VC is the clearance volume, and if we consider that VS is the swept volume, so the total volume will be VC plus VS. When the piston is at the BDC, then total volume will be there, and when the piston is at TDC, that clearance volume will be there. Now let us start with the compression process. So if we consider that start with BDC, and point 1 is at the BDC, so when the suction is completed and we are starting to compress it, then the compression will occur, and that compression will be similar to that of the without clearance, because it is having the 3 possible processes again, that is polytropic process, isothermal process, and reversible adiabatic process. Now let us discuss for this session only for the polytropic process. So 1 to 2, which is general process. So 1 to 2 is a polytropic process that we can have for the compression. Then next is there, that is when the piston is moving from the BDC to TDC, there will be compression and pressure will be increased up to the P2, up to certain stroke length, and then there will be the next process, that is delivery. So from 2 to 3 the delivery will occur, which is at constant pressure. The delivery will be continued till the TDC is reached. So that is occurring at the P2 pressure. So we can say that after the delivery ends, that is delivery pressure processes end at the point 3, there will be certain volume VC, that is called as clearance volume, and that much amount of the air will be exist in the cylinder, which is at very high pressure P2. So high pressure air at point 3 will be available, and we will start the next stroke, that is piston will start to move from the TDC to BDC. So due to which the very high pressure air is going to expand. So that high pressure air is going to expand with the polytropically, and that expansion process will occur 3 to 4. Now see, you have to note that when the piston is moving from TDC to BDC, the suction process will not start, but the expansion of the air which is available at that point 3, which is at very high pressure, should be expand first, and pressure should be reduced below atmosphere. Then and then only we can have the opening of the inlet valve, because inlet valves are open based on the pressure difference, and on one side of that inlet valve we will have the atmospheric pressure. So you have to create the less pressure, or the pressure below atmosphere inside the cylinder. Then and then only the inlet valve will open. So suction will not start at point 3 or at the TDC, but you will have the expansion of that pressurized air which is available in the clearance volume, and that will occur again polytropically from 3 to 4. Now at point 4 you may have got the pressure below atmosphere, and now the pressure difference is applied across the inlet valve, and the suction will start. So that suction will occur from 4 to 1 at the constant pressure P1, and that we are saying that suction pressure. So likewise we can have the suction process. Now from this diagram we can see that the complete cycle is there, and from the diagram we can see that the swept volume is different than whatever the volume we have sucked. So the volume sucked is called as effective volume. So amount of the air is coming inside the cylinder is not equal to the swept volume, but it will be less because we are having the expansion from 3 to 4 and suction is only from 4 to 1, and that volume is called as effective volume. So in case of consideration, when you are going to consider that there is a clearance, the effective volume sucked is always less than the swept volume. So due to the compressed air in the clearance volume, we can say that effective volume sucked is always less than the swept volume, and this may cause the reduction of the capacity of the compressor. So the volume Vs we are sweeping, but out of that only Ve we can suck. So due to the clearance, for the same capacity of the compressor, you have to increase the swept volume, means you have to increase the size of the compressor. So that is the first drawback of the clearance, that for same capacity you will require larger diameter as well as larger stroke length, or you can say that larger dimension cylinder. Okay, now this effect can be studied with the parameter volumetric efficiency. So volumetric efficiency is nothing but the actual volume sucked, that is effective volume, divided by swept volume, and this volumetric efficiency will indicate that how much percentage of the air you can suck as that of the swept volume. So if the volumetric efficiency is less, means what, that you are sucking less volume with the same swept volume, and that may cause the larger size of the cylinder. So this is the volumetric efficiency definition, and that you have to remember. So there is one derivation which may come in the examination. Let us derive that, the formula for the volumetric efficiency. So what is meant by volumetric efficiency? That is actual volume Ve divided by swept volume, and we are knowing that V is nothing but V1 minus V4. So I have replaced that V with V1 minus V4 divided by Vs. Now V1 is what? V1 we can write, it is a total volume, and it is nothing but the Vc plus Vs. So I have replaced that V1 with Vs plus Vc minus V4, that divided by Vs. Now I can separate these terms and I can get the volumetric efficiency Vs1 Vc by Vs, V4 by Vs. Now I have defining, so before that we are knowing that V4 can be calculated in terms of the pressure P3 and P4. So that can be written like this, that is V4 is equal to V3 P3 upon P4 raised to 1 upon N. In this case V3 is nothing but the Vc, and P2 by P3 by P4 is nothing but P2 by P1, because delivery pressure is same, that is P2 and P3 are same and P1 and P4 are same. So you can replace that P3 with the P2 and P4 with the P1. So I have got the V4 in terms of clearance volume and the pressure ratio. Now this can be written like this, that volumetric efficiency is 1 plus Vc upon Vs, and if you put that V4 here, then it is Vc upon Vs, P2 upon P1 raised to 1 upon N. Now in this case you can take that Vc upon Vs common, and we will have the final derivation like this, that is volumetric efficiency is equal to 1 minus C into bracket Rp raised to 1 upon N minus 1, where C is the clearance ratio Vc by Vs, while Rp is the pressure ratio. It can be written as P2 by P1 or P3 by P4. So this is the derivation for the volumetric efficiency, and this is very important derivation as the exam point of view. You have to remember while solving the problem also, this formula may be used for a lot of number of times. So you should prepare it well for solving the problems.